This is my XT clone, my latest addition into what appears to be a whole collection of XT-based machines. It's one of these generic clones. It's a CAF Turbo College. It features a 30 megabyte hard drive, MFM, two 5¼ inch floppy drives, and a typical case that you see on most XT clones from that day. Moving to the back of the case, we have the power supply. We still have the original warranty sticker that we cannot remove in order to avoiding the warranty. We have a keyboard connector. We have what appears to be a Hercules card with a parallel port, two serial ports, and another parallel port. There is a model number printed at the back, which is Turbo College 1241A, but I didn't find any information on it online. But the reason why I'm making this video is because the computer doesn't seem to start. Now, the seller did inform me that there were issues with the power supply, that the fan would briefly start, then it would shut down, and the computer was basically dead. Now, based on what the seller told me, the issue needed to be on the motherboard somewhere. The power supply turned out to be fine, as it could power a hard drive without being connected to the motherboard without any problem. So therefore, the short needed to come from the motherboard. It can either be like a bad capacitor or another component which causes a short. So we needed to look for that. So here we have a good view of the XT motherboard and the major problem area, which is the power connector over here. So we're going to be taking a closer look at that. Now, if we take a closer look at the silk screen of the power connector, what we see are, from right to left, 3 pins for the plus 5 volts, 1 pin for the minus 5 volts, 4 ground pins, 2 of which are covering each connector, minus 12 volts, plus 12 volts, another 5 volts, and a power good connector. He also told me that the board has been recapped recently because there were issues with the board previously. After that, the system did work for a couple of days, but recently it just wasn't turning on anymore, and I guess the seller was just fed up with it. Now, capacitors on these boards are known to fail, and they can cause shorts on the motherboards. So these are the primary attention points that we're going to be focusing on. So I started the investigation by taking my multimeter and probing the power connector pins. Now, the center pins on the power connector are the ground pins. So there are 4 of them, so they should provide continuity. We have the 5 volt pins on the left side here. And then we have the 12 volts and the minus 12 volts. So let's see if there is a short somewhere. So let's look at the 5 volts. That's okay. Let's take a look at the minus 12 volts. And oh, there we see a short. So there lies the problem. Okay, so there are many things that could cause a short like this. Now, given the fact that the short wasn't originally there, obviously, we need to look at some components located around this minus 12 volt supply. And we quickly discovered that there are a number of capacitors there. So my guess is that one of these capacitors will probably be bad. Now, as you can see, I flipped the board around and I've noticed that there are 2 capacitors very close to the minus 12 volts, and I'm assuming it's going to be this one. So I'm going to be desoldering it, and before we do that, we're going to apply some extra solder onto the pins on the back. This will make it a lot easier to desolder the capacitor. So I'm going to be using my simple pump to pump away the excess solder. So I'm going to be heating it up, getting my pump into place, and then just sucking up the solder. So this will require a couple of tries before everything is pulled off and we can safely remove the component. So this one should be okay, so let's go ahead and do the next one. So sometimes you need to do this multiple times to make sure that you actually fully release the pin. So this should be good now. I'm just going to see if I can wiggle the pins so that the component can be removed relatively easily. And sure enough, with relative ease, we can remove the capacitor from the board and see if the short has disappeared now. So here's the capacitor we pulled from the main board. It's a 10 microfarad 25 volts capacitor. And now let's see if the short is still there. So we're taking our multimeter and connecting it to ground and the minus 12 volts. And there shouldn't be anything there, which is good. Now to check the health of the capacitor, I'm going to be using my ESR70, which is a tool that allows you to not only measure the capacitance of a capacitor, but also the ESR value, the series resistance of the capacitor. Now what we want to have is a low ESR value. So let's hook up the clips. It's analyzing. It has an ESR value of 9 ohms and it's marked it as being in-circuit leaky. So this capacitor seems to be bad. It has a high ESR and it wasn't able to measure the capacitance. So I'm going to be fitting a new capacitor, this time rated 35 volts, but same 10 microfarad capacitance. And we're going to be doing the same measurements. So I'm going to be using my ESR70 again and hooking it up to the new capacitor and seeing what it reads. So it's analyzing. So as you can see, it has measured 10 microfarad capacitance and a very low ESR of 0.4, which is very good. So all we need to do now is pick up our new capacitor, make sure we pick the right one, and solder it onto the main board. With the new cap in place, we can check if there are no shorts between the minus 12 volts and the ground. So this seems to be okay now, and we're ready to start it up. Okay, so now for the moment of truth, let's flip the switch. We can hear the power supply fan spinning. We're just waiting to get something on the screen. We can see that it's doing its memory test. This one has 256 kilobytes of RAM. It has detected 2 serial ports, 1 printer or parallel port. We can hear the disk drives initializing, the hard drive spinning. It's an 8088 turbo systems from Arso Itri. No idea what that is. So it's dated 1987 and it's booting from the hard drive right now. So in the end, I think the system was definitely worth saving. It has 2 5¼ inch floppy drives that seem to work fine. One of them has a problem with the switch, but I think it's fixable. It has a power supply that works flawlessly now. A big MFM hard drive. I think it's 30 megabytes. I'll need to check later. We have a 256 kilobytes of memory on board. I think it will be expandable to 512 or 640. I'll need to check with that. And as far as expansion slots are concerned, we have a floppy drive controller, serial port, parallel port, hard drive controller, and a Hercules graphics card. The capacitors we've looked at on the XT motherboard were tantalum capacitors. We can use the same technique using more modern electrolytic capacitors, such as on this more modern main board here. So we've identified a couple of capacitors on the board which are faulty. So let's take a closer look and see how we can identify those. So as you can see, these green capacitors here are actually bulging, and they have been leaking electrolytic material, and it has been dried up. So you can see here from this brownish color and the fact that it's actually bulged. So this one, for example, is only bulged. It doesn't have any brown material, but it isn't 100% flush. Now if you look at some other caps on the board, like these blue and brown ones, we see that the top is actually completely flush. So with these there is no visual indication that there is something wrong with them. Although to make sure, we actually do need to measure them. Now the key takeaway on these capacitors is that if you see bulging capacitors or leaking capacitors, they're obviously going to be bad. But that doesn't mean that capacitors that look completely flush and don't indicate that they are leaking, that they are in fact still working properly. So you'll always need to measure the capacitor. Now I went ahead and desoldered this bad capacitor, which is a 1000 microfarad 6.3 volt capacitor. So we're going to be measuring that using the ESR70. As you can see, it's bulging and it's leaking electrolytic material. So as we've seen on the XT motherboard, as we measure this capacitor, we see it's in circuit leaky and it has a very high ohm equivalent series resistance. So obviously the capacitor is bad. Now if you take a look at another capacitor, one that appears to be fine in the sense that it isn't bulged and it's not leaking, let's see what it reads out using the ESR70 meter. So this is a 100 microfarad 16 volt capacitor, and we're going to be connecting it to the ESR70 to read its values. So here we're hooking it up. The ESR70 is analyzing the component, and it has found the capacitance value of 97 microfarad and a very low ESR reading of 0.3 ohms. So all in all, replacing the capacitors was an easy fix to get the machine up and running again. So it just goes to show that this very simple component can make the machine look pretty much dead, and a simple fix is just replacing that simple component. Now there are still some other issues that we need to tackle with this machine. For example, the self-test only reveals 256 kilobytes of RAM, while I'm pretty sure there is 640 kilobytes of RAM chips on the board. PC Tools also sees 640 kilobytes of RAM, while MS-DOS only reports 256. But all in all, I'm happy with this fix. I'm sure we'll sort these problems out in a future video. For now, I'm going to be focusing on installing some new software and new hardware onto the machine and keep you guys posted here. So please subscribe, like the video, and bye for now.